Here we go, everybody. Homework answers for the first day of Unit 4. We had to do 5, 6, 7, and 8. And it says for exercises 5 through 8, find the critical value that corresponds to the given confidence level. Okay, so let me go to the homework. And here it is. All right, so in number 5, it said a 95% confidence level. That means alpha equals 0.05. This is straight from our notes. If alpha equals 0.05, split it in half, you get 0.025 in each tail, which means there's 0.475 out to each tail. And you look that up backwards and you get 1.96. Skipping all the way to number 8, it was a 99% confidence level, which means that alpha equals 0.01. And if you split 0.01 in half, you get 0.005 and 005, which means 0.5 minus 0.005 is 0.4950. And the z-score is 2.575. Memorize those. When alpha is 0.05, the critical value, it's called. It's a z-score, but it's called a critical value because it's a critical value that creates those boundaries. Critical value is 1.96. When alpha is 0.01, the critical value is 2.575. But, all right. It said the confidence level is 0.96 here, which means the alpha level is 0.04. This is the very last thing I did on my lesson, if I can remember. So split 0.04 in half, you get 0.02 and 0.02. And then you're looking up 0.4800 backwards, and you get 2.0. Last but not least, it says it's 92% confidence level, which means alpha is 0.08. Split 0.08 in half, and you get 0.04, 0.04, which means you're looking up 0.4600 backwards on your z-table. The closest z-score is 1.75. Pause this video and try it for yourself using the z-table if you're having any difficulty doing that, okay? Because that's a key component. Being able to use your z-table and look at it backwards to find particular z-scores. All right, then you had to do 9 and 11, which were sample size questions. Let's look at the book. Okay, so for 9 and 11, it says, calculate the margin of error, E, and it says if the requirements are not satisfied, state that the margin of error cannot be calculated using this method. So in other words, if there's not enough information. So number 9 says the confidence level is 95%. Sample size is 100, which is greater than 30. And sigma is 15. So we have a large enough sample. We have everything we need. So it said 95% confidence, which means alpha is 0.05, which means the z-score is 1.96. But and so you just plug in sigma, which is 15, divide by the square root of 100, and you get 2.94. Done. In number 11, it said 99% confidence level. So that means alpha is 0.01. What's the z-score for that? 2.575. But and you plug in 15 for the standard deviation again, and this time the sample size was 9. So divided by root 9. The reason why we're able to do this is because it said in number 11 the population was normally distributed. I'll get back to that. You get 12.875. Just for confirmation, this is what I'm talking about right here. So number 11, and it says the population in number 11 is normally distributed. Remember, the central limit theorem states that the sample sizes have to be greater than 30 unless the population is already normally distributed. Okay, so the central limit theorem can be used. What was the next problem we had to do? 14. So what do we have to do? 14, 15, and 28. Let's just look at those before I move right along. So for 14, I wish there was a way I could do a split screen. As of right now, I don't have the technology for that. I'm actually looking into Google Meet and seeing if it's more efficient. But for right now, we're using this. All right, so 14, 15, and 28. So here it is. It says use the given confidence level and the sample data to find the confidence interval, estimating the population mean mu. So it says for 14, speeds of drivers are 55 miles an hour. We want a 95% confidence interval. Sample size is 90. The sample mean is 66.2. That's what we're building the confidence interval around, the 66.2. So it's going to be 66.2 plus something and 66.2 minus something. Sigma is 3.4. Before I even go back, so I don't have to keep flipping back and forth, 15 is a 99% confidence interval, 2.575. And sample size 70, X bar is 688. That's what we're building the interval around, 688. And sigma is 68. So since 14 is a 95% confidence interval, what's the z-score? It's 1.96. That's right. And the rest is just plug it in, plug it in. You take 66.2 minus the error, less than mu, less than 66.2 plus the error, and you get an interval that goes from 65.5 to 66.9. Mr. Colodi, do I need to write it as this inequality and probability? Yes, write it as that. Equals 0.95 because it's a 95% confidence interval. Then a verbal. We are 95% confident that the true mean speeds are between, I was lazy, sorry, 65.5 and 66.9 with a best point estimate, BPE is best point estimate of, what's our X bar? 66.2 miles per hour. There we go. There's the whole verbal. Sorry, I was lazy. Normally I'm doing this in class in person. 15 was a 99% confidence interval, so we're using 2.575. That doesn't change. See how I'm saying how this is like butter? All right, so I plug all the pieces in. So 688 minus the error piece, less than mu, less than 688 plus the error piece, and there it is. Now, people ask me, Mr. Colodi, what should we round these confidence intervals to? I would say at least 1 or 2 decimal places. That said, I broke my own rules. I rounded it off to the nearest whole number for 15. My apologies. Round it to at least a decimal or 2. And then your verbal. We're 99% confident that the true credit rating scores are between 667 and 709 with a best point estimate, BPE best point estimate of the X bar of 688. Last but not least, 28. Let's go to the book. What does 28 say? 28 says when people smoke, the nicotine they absorb is converted to cotinine, which can be measured. The sample of 40 smokers at a sample cotinine level of 172.5. Assuming that sigma is 119.5, find the 90% confidence interval. 90% confidence interval. All right, so let's go to the answers. So because it's a 90% confidence interval, I want us to think about this right here. 90% means that alpha is 0.10, correct? If it's 0.90 in the middle, that means alpha is 0.10, which means if I split 0.10 in half, I get 0.05 here on the right. I get 0.05 here on the left. And that means that I get 0.45 here. I don't have my z-table handy, but 0.45 is the only other area that produces a special z-score, and that z-score is 1.645. It's directly in between 1.64 and 1.65. Look that up. So that's what I used for my z-scores here. The rest, just 172.5 plus or minus the error piece, and I get an interval that goes from 141.4 to 203.6. And we are 90% confident that the true mean cotinine levels are between 141.4 and 203.6 with a best point estimate of 172.5. Last but not least, you had to do 33, 34, and 36 sample size questions. Let's look at the book 33, 34, and 36. Okay, so it says an IQ test. Basically, you're just plugging in all the values that they give you in 33, 34, and 36. All right, the big thing about 33 is that you want to be 95% confident in your results, 1.96. For number 34, you want to be 99% confident in your results, 2.575. And last but not least, 36, you want to be 96% confident. Ooh, that means alpha is 0.04. So let me go back to the homework. I do believe that up top here, we did alpha was 0.04. It's right here. When alpha is 0.04, the z-score is 2.05. So keep that in mind for number 36. So for 33, 95% confident, 1.96. I just plugged in all the values into the equation that I gave in the notes. The z-score, I'll just write it here one more. The z-square times sigma all over the error piece, quantity squared. That's n. And so there's the z-score times sigma over the error piece 2 squared, and I got 216.09. Remember, you're always rounding up. For number 34, 99% confidence, so 2.575. Plugged it all in, squared it, and I got 49.06 on my calculator. Round that up to 50. And last but not least, the alpha level is 0.04, so the z-score is 2.05. Plug it all in, square it, and I got an answer of 235.13 on my calculator. Round that up to a sample size of 236. I love sample size questions. Why? Because they're basic. You just plug in the data, get an answer in a minute. Okay, there's the homework. I hope this helped. I could do a Zoom meeting tomorrow on Wednesday if it's helpful in the morning. If people want to go over it together. Bye.